anything from the homework from the past couple, just Monday, but anything from Monday's homework that you'd like to take a look at? For this chapter, I do try to spend a little bit more time on homework because it's so new for you. So 9, sure. All right, 9. So we're just solving for x. And so what is my base in that problem? Anybody? What's the base for number 9? Yeah, our base is base e. And so if you have base e, we don't just use any log. I thought it was on the whiteboard, but it's not. We use ln. So I'm going to take the ln of both sides. So I will have ln of e to the x is equal to ln of 7. Notice, the items that I had in the problem just get dropped straight into the argument of the log. So once I got that, what happens? Do we cancel something? Do we multiply something? Do we go to our calculator? What is the next thing that you do? We're going to cancel out the ln and the e. So this will cancel out. This is the inverse operation. This is the whole reason that we're doing this. Over here, that doesn't cancel out. And so I'm going to be left with x equals ln of 7. Now, if I asked you for an exact answer, that's it. You're done. And later on in the unit, we'll start talking more about exact answers. But sometimes that would be the answer, and that's what we would want. You wouldn't go any further than that. If it's not the answer, then we got to type that in. I do have calculators up here. I normally don't ask you to trade, but today I do want you to trade because we don't have our red calculators. I have to paint them yet, and we do have to use these for the pre-ACT in a little bit of time. So if you do come up for one and borrow one, just please put a student ID or a phone or something in there. We'll go ahead, type it in. ln of 7. So when I write this, I would write this as approximately 1.9459, then there's a 10, but I don't want to write all that. I want to go to the thousands place, the 3 decimal places. So if I do that, that actually takes me down to 1.946, okay? If you already wrote down 1.95, that's fine. You don't need to change it, but just watch out for that in the future. Questions? Other questions on your homework? Anything that you couldn't do or didn't know how to or just weren't sure about? 4? I think that's on the first page. Maybe not. All right, number 4. So you'll notice with a lot of these log problems or the exponential portion, a lot of times we always have addition or subtraction that we have to get rid of, and then we always are multiplied by something we have to get rid of. So we're going to tackle that first. So I'll plus 1 to both sides, and I get 12.5, and then log base 5 argument x equals 25. The goal here, again, is to get your log by itself. Next thing that I do, I'm going to divide this by 12.5. That cancels. And I divide by 12.5, and I get log 5 argument x is equal to 2. Most of the time, those steps are not the problem. So let's dive into this. How do I change this log from the log form to an exponential function using my inverse operation? What am I going to do? How so?
Like taking the 5 out from the log and I guess using that 2 squared.
Yes, I'll take that. That's good. So I'm going to dive a little bit more into that. So you can start jumping there, but remember that logs and exponential functions are inverses. So if I want to get rid of this log so that the 5 does get over there, okay, I'm going to take these two items and make them my exponent. That's the inverse operation that's going on. And so we do end up exactly with what Blake had talked about. So I'm going to cancel that out, and I get that x is now equal to 5 squared, or x is equal to 25. Questions? All right, anything else from your homework? Number 8. So we got an ln. We talked about actually the counterpart over here, base e, right? So we do have a log base e. If it does help you, you could write this on your test to kind of remind you of that. We don't write that for you. We're not going to. But if you are struggling to remember that, if you had to memorize that quick, write it down on your paper, that's not a bad thing to write down. Now, when I look at the ln of x plus 2 equals 5, I'm going to do the same thing I did up on number 4. I'm going to subtract away the 2 and get the ln by itself. So I get this natural log by itself, and it equals 3. We already said our base is e. I'm going to do kind of the same process. I'm going to raise these up as an exponent. So I'm going to have e to the ln of x is equal to e to the 3rd power. And so the e and the ln are canceling. That's, again, that key piece. If we get that, we'll be in a really good place. So canceling that out, I end up with x equals e to the 3rd power. And this actually goes just like number 9. If I'm asking for an exact answer, e to the 3rd power is an answer. If I'm asking you to approximate that, then you type it in. And when you type it in, we get approximately what? Anyone got it? I don't know that one off the top of my head. 20.086 is perfect. And again, we got our exact answer, and we have an approximate answer. I think that was a healthy dose of homework to start our day. Nice job with the questions. You can go ahead and flip. I'll give you some time at the end of class as well to get some homework as well. So starting our lesson today, you notice that we have something a little unique. I have 2 logs in one problem. That's not the nicest thing to look at. So we would actually simplify this. We would condense it. But we don't know how to condense it. So we're actually going to skip this problem and come back to it later on. So we're going to start with our product property. What I want you to realize is the exponent properties are just being translated to your log properties. So when I look at the product property here, this is going to be the same as, I'll try to be a little nicer when I write this out instead of getting all messy. It's going to be log base b with an argument of x, and I put a plus sign between them. And then I put log base b with an argument to y. Instead of going to the problem up above, we actually have the same problem down below in your note packet. We're just going to apply this. So if I look at example 1, this is going to, I lied. I'm going to do example 2 because 2 is harder, 1's easier. So I'm going to do 2, you're going to do 1. So I'm going to write this as log. What base is this, by the way? 10. So with base 10, I don't have to do anything with that. So I get log of 6 plus log x plus log y. So if I was expanding my log out, I'd be done with it. A benefit of expanding here is if you notice, when I expanded this out, I now have log 6. I could calculate that if I wanted to. You don't need to. We're not solving anything right now. We're just expanding. I want you to expand number 1. I don't think there's ever been so much room in this room. Your desks are so far apart. And from what I've seen as I walked around, we looked pretty good. I get log base 2 with 3 plus log base 2 of x. Questions there? If I'm condensing, it's going to work the same way. I would put these things together. Now, I want you to caution yourself from just going from that to your answer. Go by steps. Break it down. Slow it down. If you slow down, we write this test so you have plenty of time because we want you to slow down, put the steps down so you don't make any silly mistakes. My first step is just going to put all of those pieces together. I'm going to multiply them all out. So I'm going to have x times 4 times 7. Not decimals, multiplying. My next step would simply be to multiply what I can multiply together. So I can multiply 4 and 7 together. We get 28x. That would be my answer. That's kind of what we would expect to see in terms of work. Not a ton, but enough. Questions? I'm going to go to my next slide. This is just on your paper yet. This property, division. For exponents, if I have division, what do I do with those exponents? You subtract. Yeah. So we do the same thing here. I'm going to have log base b, argument x, minus log base b, argument y. I'll do example 5 again. So if I'm writing this out, this is where it gets a little bit tricky. We have 2 options that could happen. My first option is going to be to write it like this. Log base 7, argument 7, minus log 9x. This is where it splits, and you can choose however you want to write this. The method that I prefer is to simply take everything in the denominator and put a big bracket in front of it. And I do that because that minus sign is screaming, this all goes in my denominator. All right, so let's see how it goes. So I'm going to have log base 7. I'm going to have 9 right here. What am I going to put though? 9 times x. What do I put between those 2 things? What was your last property? Said if you multiply together, you put a plus sign between them. So I'm going to put plus log base 7 argument x. This minus sign in the front is telling me that everything to the right of that goes in my denominator. Sorry. The other option, which is not a bad option, there's nothing wrong with it, I just prefer this, I think it's more efficient, is to distribute that negative and write it like this. So that's just telling me again, everything goes in my denominator. I do like this as the better option. I think it's simpler. However, if you like the other one, go for it. I have both answers on the test. I accept both. Questions on 5. You get to tackle 4. Don't do number 6. I'll help you with number 6. Lots of people wrote it like this, and that's good. That's the best answer, I would say. However, you could, if you want it to be difficult, write your answer like this. Because that negative is telling me that this goes down into my denominator. That positive is telling me that x goes up in my numerator. Go with the simple option. Okay, write it how you did write it. But just realize there's options. I wrote that because on this example, this is log base 10, argument of x. I'm going to go ahead and put that x on top of my fraction. So I got an x right there. Then I'm going to go ahead and subtract away the log with an argument of 4. So I'm going to put that here. And then I will put a plus log 7. Again, I'm spacing this out, taking a little more time with it. So now we get to the question. Does the 7 go to the top or does it go to the bottom? I'll write this down. So if it's a plus, it's going on top of your fraction. If it's a minus, it goes on the bottom of my fraction. And because it is a plus, I'm going 7 times x to the 4, or x divided by 4. So I would write this as log 7x divided by 4. That would be the condensed version. Think about this like a conveyor belt. You have your conveyor belt, it's pushing your log forward. If it has a plus sign, it kicks up and it goes up the track and drops down onto the top of your fraction. If the conveyor belt's going and it senses a negative, a minus, then the track drops and it gets pushed down into the denominator. So that's just the way that you can look at those to sort them very quickly. Any questions there? Flip the page if you're ready. Power property. So the power property goes like this. I have an exponent on the outside of that argument. It actually can go inside, it doesn't really matter. But we just put it there so it's really popping out at you. So to write that, I can actually write this as log, or y times log base b argument of x. I'm going to show you example 8 because we're putting a lot of properties together. We're putting our first two properties along with this last property. So how do I do that? The first thing that I'm going to choose to do here is I'm going to break my log up. I'm going to break it into the positives and the negatives. So I'm going to have log 2y cubed minus log 10. Next, I'm going to split up the 2 and the y cubed. So I'm going to have log 2 plus, because I'm multiplying those pieces together, log y cubed minus log 10. Lastly, I just go ahead and I take that 3 and I put it in front of the log that has the y. So I'm going to copy and paste the log 2. And then I got plus 3 log y minus log 10. We tackled the division first. Then we split once we had our numerators and our denominators separate. Then we dealt with what was going on in there. And then the last thing we did is we dealt with that. Okay? Now think about this. If I'm expanding, that's going in one direction. If I'm condensing, I go in the opposite. So then I would be starting here, like I would on example 9, and I'd work my way back. Now we're going to take a look at 7. I just want you to write it out. It should be a quick one. There's not a whole lot for you to do. So try 7 really quick. I'll just take a glance as I walk through. So your goal is just to get rid of that exponent. It is not being multiplied, so there shouldn't be a plus sign on this. We just want the base stay exact same. The tree is there. So we take our exponent at 3 and we toss it into the front of our log. So I get 3 log base 2 with an argument of x. Example 9, we're condensing. So the first thing that I deal with is my exponents. I take all of these numbers out in front, the 2, the 3, and then the 5, and I toss them on top as an exponent for all of these pieces. This becomes ln x squared plus ln y cubed minus ln 2 to the 5th. All of my exponents, the numbers in front, got moved, so they are now back to being exponents. All of these problems that we've been doing, what do you notice about the logs that we look at? So for example, 8, what base do I have for all of 8? Yeah, base 10. If I look at this one, I have all base ln. If I go back, I always have the same base in that problem. What does that mean? If I would go ahead and add plus log 5, don't write that down. Do you think I can condense it with these things? No, because it doesn't have the same base. So all of these problems do have the same base, but I also want to just point it out so you know that they need to have the same base. Where should we go from here? There's different options, and I'll listen to them all. What should we do? My goal is to just write ln one time. So how do I start simplifying that? Ava, you're getting pulled in. What do you think? Give me a guess. Wrong answers are fine right now. This is brand new to you. You've never seen it. We could move the exponents. If we move the exponents, we're going to get right back to where we were. So it would be like undoing what we had kind of done. And that's fine. That's a good thought. You do want to tackle those. Yeah, go ahead.
Do you write just ln once and then do parentheses and then do like a fraction?
You are going to get a fraction. Now, I'm going to add a step, okay? But you're correct. So I'm going to do this in purple so we can see just an additional step. I got a plus sign here. What's that telling me to do with their arguments? It's telling me to multiply. So I'm going to get x squared times y cubed minus ln 2 to the 5th. Now, I'm going back to blue because I'm going to go with what Chandler said. And he said to make our fraction bar. I like that. I'm going to put these items on the top or the bottom. The top, good. So I get x squared, y cubed. And then I'm going to have, oh, I never finished that parenthesis. And then I'm going to have 2 to the 5th right there. Because it's negative, so it's going to the bottom. Either one would be fine for today, but this is ultimately the goal. If we know what 2 to the 5th is, we want to write it down. Questions? It's so sad looking out the window right now, I'm not going to lie. I thought we were done with all that stuff. Wasn't it like 65 on Monday? So sad. So sad. Now we practice. So we're going to break these things apart. Example 10. How do I break that thing apart? What do you think, Aiden? So we will tackle the exponent, but we can't tackle it first. Because if I tackle the exponents first, do I put the 2 out there or do I put the 4 out there? Right? Because this x squared, that square is only affecting the x. So I got to get x by itself first. That's a good idea though. We are going to have to tackle the exponents. So let's try to break them from top and bottom. I can write this as log 5x squared minus log 3y to the 4th. We got to break it up just a little bit more. So think about this. Do we want to use a bracket for the subtraction, or do we want to just go minus sign, minus sign? What do you want to do? Minus, minus? Okay. So this top part, I am going to use a plus sign, right? So I'm going to have log 5 plus log x squared. The bottom, I'm going to change the color on, is going to be minus log 3 minus log y to the 4th. And now we get to that step. Now I deal with those exponents. So if I am expanding, exponents are the last thing I deal with. If I'm condensing, exponents are the first thing that we deal with. So lastly, we just get log argument 5 plus 2 log x minus log argument 3 minus 4 log y. Questions? Tackling 11. Kaden actually already gave us our first step. We're going to tackle the exponents. So I want you to try to put all the exponents on those numbers really quick. And then I'm going to write it. And then we're going to look at what happens on the next step. That's what we get. Now my recommendation is always work with the simplest form of whatever we're looking at. So if I'm looking at that, I see 2 things that can be simplified. What can we simplify right away? Yeah. Simplifying, we get ln of 125. I don't do anything here. I get ln of 9. And then I just got ln x back there. Now that we're here, I'm comfortable if you go ahead and you think about that conveyor belt and you put the positives on top, the negatives on the bottom, and see if we have to do anything else. This gives me ln. Got a fraction bar getting dropped here. So 125 is positive, and the ln of x squared, also we got a positive there. I put both of them in. I will be subtracting 9 and then x. So they get put together because we're multiplying again. So I'm going to have 9x right here. Yes. It is. I missed that. So thank you for catching that. Let's tack that 3 on there. Right up here, this very last one, this should be x cubed. So this should be x cubed. And that makes this down here x cubed. Now, like I said, I always want you to work with the simplest. I don't. That's not the simplest it can be. I'm going to write ln one more time. 125 divided by 9. Can we simplify that? No, it's just 125 divided by 9, which is fine. X squared divided by x cubed. What's that simplify to? Just x, top or bottom? Bottom, good. So I get 125 divided by 9x. Questions? Have you seen a plus sign today in a condensed form? No. So if you are condensing something, chances are you don't have a plus sign. Chances are you're just multiplying those pieces together. Do we got questions? This is back to example 1. It's example 12 for you. We just wrote it twice for you so you don't have to flip back. So example 1, how do we solve that? Well, what's this plus sign telling us to do? Yeah, you gotta multiply these two things together. So I'm going to have one log, I'm going to have log base 2, but I have to multiply those two things together to get my argument. You've done this for a while now. So x plus 2 times x plus 4. Let's double distribute that. See what we arrive to. I'll do it up here. You do it on your paper. We should get x squared plus 6x plus 8. So the work is shown up here. Now, variables in my argument. So if my variable's in there, I need to change it to an exponential function. What operation is going to do that for me? What's the inverse operation that I can use? What number am I going to use? 2. Yeah, I have a base of 2. So Monday was all about that base. So this becomes 2 to the power, okay, that's an exponent now, and 2 cubed. So we're really just changing forms. But this is why it works out. So I cross that off, and I'm left with this lovely x squared plus 6x plus 8 equals 2 to the third power. What's 2 to the third power? 8. So I get 8 over here. Oh my gosh, this is going back to like chapter 5. Deep breaths, folks. If I want to solve something like this, how do I do that? One strategy is get it to equal what number? 0. Yeah, so I'm going to minus 8 from both sides. I want this 8 gone, but your math teachers were actually really nice for once. Don't get used to that. But we are really nice, and this also cancels out. And so now I'm left with x squared plus 6x equals 0. You can always use the quadratic formula. You could complete the square. Nobody's probably jumping out of their chair to do that one, or the first one. We could also factor. What can I factor out of this? X. So I'm going to have an x. This gives me x plus 6. Back in chapter 5, I wouldn't even write down the rest of this problem. I'd just give you the answers and be like, you guys are good, you got this. But it's been a little bit, so I will remind you. We set these equal to 0 then, using the zero product property. So I get x equals 0 from this x right here. And this part gives me x plus 6 equals 0, leaving us with that x equals negative 6. Oh, you think we're done, right? But we're not. We have to check our logs. I suppose I should draw this on the board since we're doing a video. If I graph a log, typically it looks like this. So do we ever get an answer over here on the negatives? No. Do we get 0? No, because typically your asymptote is right on there. Now if I shift it, it shifts my numbers, so we have to check. So what I'm looking for is, if I plug this in up here, if I plug 0 in, do I get a negative or do I get 0? So if I plug 0 in, I get 0 plus 2 is 2. My argument is a positive number. Don't care about the rest of the problem. Then I go over here, log 2, and I put 0 in, still get 4. It works out, right? Still positive number. Inside this argument, 0 is a good answer. What was our other answer? Ooh. We take negative 6, we plug it in here. I get log base 2, and I get negative 6 plus 2. If I work through that really quickly, I get 2 to the negative 4. Change of base on your calculator says that you would take log of negative 4 divided by log of 2. Type it in, because I want to get you used to understanding that your calculator is telling you the answer, even though it doesn't tell you the answer. So type in log negative 4 divided by log 2. What does yours say? Math error. Other ones, what does yours say? Domain error? Yeah. So when we're looking at these, if your calculator takes one of your answers when you put it in there and it gives you a domain error, or it says math error, or whatever, it's telling you it's not actually a solution. So we're going to go down here, and we are going to cross this off. It's what we would call an extraneous solution. All the way back in chapter 2. It's a fake solution. Questions? Example 13. How do we start that problem? How do you condense that? You always want to condense or expand right off the bat if you are solving. So how do I condense that? Because it's already expanded. Subtraction means what? Yeah, put it as a fraction. I'll also say subtraction is like a fraction bar, right? So if I see that, it's telling me that I'm going to have a fraction because I'm going down below. So I would write this as ln. Oh, not like that actually. What base is ln? E. So I'm going to make my base e to both sides. When I do that, I'll write this whole thing out this time. E raised up to the ln of x divided by 5 is equal to e to the 7th. So I'm going to cancel this out, and I get x divided by 5 equals e to the 7th. Don't even grab your calculators for that. Leave it. Leave e as whatever it is, e to the 5th, 4th, 3rd, whatever. Leave it like that for the moment. At the very end, we can calculate. That way, if we are calculating, you don't have any mistakes. How do I get x by itself? Perfect. So we go times 5. Inverse operation cancels out. Times 5. So x is going to equal 5 times e to the 7th. This would be our exact answer. Or, approximately, let's all type it in and make sure we can get it. You must have picked up a Math 1 calculators. These things are drawn on like no other.
Questions?